Hello everyone, today we're going to be learning more about adjacent angles. I've got my friend Wrigley here to help us out. So yesterday you learned about adjacent angles with Miss Greif, where she gave you an intro lesson. Today we're going to be continuing with that, and you'll be learning more about adjacent angles. So this is Miss Reynolds. I'm one of the math teachers, and we're going to continue with our notes on adjacent angles today. So adjacent angles are adjacent if they share a vertex and a side but have no interior points in common. So if we were to look at these two examples, there's an example that shows us adjacent angles and an example that does not show us adjacent angles. If we look at this first example, it says angle AOB and angle BOC are adjacent angles. So if we look at angle AOB, and I'm going to mark it with a green marker, AOB, and then if we look at angle BOC, which I'm going to mark with a pink marker, angle BO, it's a bad line, angle BOC. So here's these two angles. They are adjacent because they share a vertex, which is right here, and they have a side in common, which their side that they share is right here. If you look at this example, angle AOB and angle COD are not adjacent angles. So if I mark these angles, I'm going to mark angle AOB with my green marker, AOB, and angle COD, I'm going to mark it with my pink marker. So if we look at these two angles, they are not adjacent. Tell me why they are not adjacent. So looking at these two angles, angle AOB and angle COD, they are not adjacent because, yes, they do share a vertex, but they do not share a side in common, so they are not adjacent. Just a side note, it says right here, these marks on an angle can make it easier to identify a particular angle. So if you look, they highlighted angle AOB in red, and they drew a little mark on angle AOB in red that shows you that that's the angle. If you look at angle BOC, they wrote it in blue. You look here, angle BOC, I know I drew over it so it's kind of hard to see now, but there's a blue line identifying that angle. So now let's look at part 1, example 1. And it says, name 4 pairs of adjacent angles. And remember, adjacent angles are angles that are next to each other. They share a vertex and a side. So if we look at, we need to name 4 pairs. I'm going to name 1 pair and I want you to name the other 3. So I'm going to name angle 1 is adjacent to angle 2. So angle 1 and angle 2 are adjacent to each other. You name the other 3. Alright, so we're going to name 3 other adjacent angles, or 3 other pairs of adjacent angles. So, we already said angle 1 and angle 2 are adjacent to each other. Well, we also know that there's more adjacent angles. We look at angle 1 is also adjacent to angle 4. They share a vertex and a side. So, angle 1 and angle 4. Now, if we look at angle 4 is adjacent to angle 1, which we already named, but angle 4 is also adjacent to angle 3. Angle 4 and angle 3. Now, if we look at angle 4 is adjacent to angle 3, but angle 3 is also adjacent to angle 2. Now, it doesn't matter when you're naming adjacent angles which angle comes first, because saying that angle 1 is adjacent to angle 2 is the same thing as saying angle 2 is adjacent to angle 1. It doesn't matter which angle comes first. They're both the same way that you can say it. So off to the side, I just wrote another way that you could say it. Saying angle 1 and angle 2 are adjacent to each other is the same thing as saying angle 2 and angle 1 are adjacent to each other. It doesn't matter which one you put first. So now we're looking at part 1, example 2, and it says, name 2 angles adjacent with angle So the first thing I'm going to do, I'm going to find angle GFH. So if I look, GFH, that's this angle. So I need to find what are two other angles that are adjacent with this angle. So we see all these angles share the vertex F, right? So we have to find what is the two other angles that share this vertex and a side with angle GFH. So if I look, angle GFE shares this vertex and it shares a side. So I know that angle GFH and angle GFE are adjacent to each other. And I just use colors to help me identify the angles. You go and find another angle that is adjacent to angle GFH. So now let's find the other angle that's adjacent to angle GFH. So if we look, here's the vertex that they have to share. And if we see angle HFI shares the vertex and it shares a side with angle GFH. So angle HFI is adjacent to angle GFH. And I just use colors to help me find my angles. Now we're looking at part 1, example 3, and it says, which angles are adjacent to angle EOD? Sorry, that's my dog barking in the background. So, first thing we're going to do, we're going to find angle EOD. So if I look, angle EOD. Here's the vertex. Here's my angles. Excuse me. So, now we got to find which angles are adjacent to it. So, you need to find angles that have the same vertex and share a side with this angle. Go ahead and do that. So, this is the angle EOD. So there are only two sides to this angle, right? So any adjacent angles to this angle either have to share this side or they have to share this side. So let's start with this side. Well, this angle right here shares the same vertex and shares a side, so it would be angle EOA. Now if we look at the other side, here's the vertex. This is the side that the angle has to share, so it would be angle DOC. So if we write our answers, I'm going to use colors to help me out. Angle EOD and start with this side, angle EOA are adjacent to each other. Now if we look at the other side, angle EOD and we're looking at the other side of this angle, they would share this side, so it's angle DOC. Are there any other angles that I missed that are adjacent to angle EOD? Now on to our favorite part, using algebra to find adjacent angles. So it says, part 2, example 1. The measure of angle PRS is 80 degrees. What is the value of x? So our notes from last week, we also used some algebra to find the value of x when we're given angles. So we're going to be doing the same thing here, except working with adjacent angles. So it says the measure of angle PRS. So if we look at angle PRS, it's this whole thing, PRS. This measure, this whole angle, is equal to 80 degrees. So if we look, there's two angles inside of angle PRS that make up angle PRS. So if we look, I'm going to use colors, angle PRQ is inside of angle PRS, and angle QRS is inside of angle PRS. These two angles make up angle PRS. So if they make up this angle, we know these two values added together equal 80 degrees. So just like we did last week, we're going to set up an equation. So I know this angle plus this angle equals 80 degrees. So 25 is the measure of this angle plus x is the measure of this angle equals 80. Now I'm going to solve. What is the first thing I'm going to do to solve this equation? So the first thing I'm going to do, I know I'm solving for my variable x, so I need to get everything else away from my variable. So on the other side of the equation, I'm going to move my constants first, which is this positive 25. So to move it to the other side, I'm going to subtract 25. On both sides, when I do that, 25 minus 25 cancels out, so I'm left with x equals, and I know 80 minus 25 is going to give me 55. And what is the value of x? So this x, it said that it was a degree, right? This was x degrees, so I know if I'm finding the value for x, this is going to be 55 degrees. So make sure you label, because you were finding the measure of that angle. Part 2, example 2, is just like the last example that we did. So it says the measure of angle ABC is 100 degrees. What is the value of x? So looking at this picture, angle ABC, this whole angle is equal to 100 degrees. That's what they give us in the sentence. So just like we talked about, we know there's three angles here, angle ABC, angle ABD, and angle DBC. These two angles make up angle ABC. So if these two angles make up this big angle, we know their measures, their degrees added together is equal to 100 degrees. So just like we did, we're going to set an equation up. I know 2x plus 60 is equal to 100, because 2x is the measure of this angle, 60 is the measure of this angle, and they make up this measure. So I'm going to make my equation. 2x plus 60 equals 100. What is the first thing I'm going to do to solve this equation? So now I'm going to move my constants first. My constant is 60. So if this is a positive 60, to move it to the other side, you're going to subtract 60 on both sides. When you do that, 60 minus 60 cancels, and you're left with 2x equals 100 minus 60 is 40. Now I'm going to solve for x. If this is 2 times x, to get this variable by itself, I need to divide by 2 on both sides. When I do that, I get x equals 20. So if you look back at the picture, this was a degree, right? This was a measure of this angle. But this 20 is just representing x. So we answered the question, what is the value of x? It's 20. But if we wanted to find the measure of the angle, we're going to have to take this 20 and plug it back in to this expression. So the measure of angle ABD is equal to 2 times 20, because the measure was 2x, 2 times the value of x, which is 20, gives us 40 degrees. They didn't ask for that, we just had to find the value of x, but that's just a little bit extra work. Part 2, example 3. Given the measure of 2 of the angles, find the measure of the third angle. So we're going to work a little bit differently in this last example. So if you see, they tell us angle SAX, SAX, this angle, is equal to 142 degrees. So this is equal to 142 degrees. Then they tell us angle PAX, so angle PA x is equal to 58 degrees. So they give us two measures of two of the angles, but we're still missing this third angle. And it says, what is the measure of angle SAP? So we're trying to find what is the measure of this angle. So if we don't know the measure, use a variable to represent it. I'm just going to pick x. So we now know these two angles make up this big angle. So angle SAP plus angle PAX equal 142 degrees. So I'm just going to write that off to the side. So I know angle SAP plus angle PAX equal angle SAX. That's my equation I just used to represent these two angles equal this big angle. So now plug in the measures of these angles. So angle SAP, we don't know what that measure is. That's what we're trying to find. So we just labeled it x. That's what we're trying to solve for. Plus the measure of PAX, angle PAX is 58, is equal to the measure of angle SAX is 142. And now we have our equation. So now we have to solve for x. I'm just going to use pencil to do that. So if I'm solving for x, I have to move my constant first. So if this is a positive 58, I'm going to subtract 58 on both sides. So when I do that, 58 minus 58 cancels. I'm left with x equals 142 minus 58 gives me 84. And I know I was solving for the measure of an angle, so the measure of angle SAP, which is what I was trying to find, is equal to 84 degrees. And just a little side note, it might be pretty helpful if you have different colored pencils or markers at home to help you highlight and find these angles in these problems. So that's the end of this lesson. If you have any questions, please contact your teachers. And at the end of this video, please leave any comments, concerns, questions that you might have.